Have you ever asked yourself, how does an electric motor work? To understand that, watch this video till the end. Hello everybody and welcome to a new video. Today we are going to be talking about motors and generators. So let's start off easy with motors. First of all, we have learned before that a wire with current passing through a magnetic field will be affected by a force, okay? Now, if a wire was shaped like in the image below, in other words, we are creating a loop with this wire, what would the forces on this wire cause? We know that the current is passing through a wire, and if we use the right-hand rule, we know the direction of the magnetic field is going from the north to the south, and we know the direction of the current, we will find out that the force is going downwards. But on the other side, if we look right here, it's like the current switch its direction. So now the current is going downwards instead of going upwards. If we use the right-hand rule again, we will find that the force is going upwards. Actually, this force going downwards and this force going upwards will cause this loop of wire to rotate, and that is the most simple concept behind a motor, using the idea that when a current is passing through a wire in a magnetic field, it will cause a force. So we shape this wire into a loop and we are causing this loop to rotate, okay? Now let's go a little bit more deeply into motors. Now, imagine you are looking at the front side of the motor. So you are looking at a section or a cross section of this motor. Now, and let's start from this image right here. Here the current is going away from you, and here the current is going towards you. If you use the right-hand rule again, we have the magnetic field. We will find that the force is going downwards, and here the force is going upwards. So now it's causing it to rotate. Now it's rotating counterclockwise, okay? Now, here let's look at the second image. It started rotating. At a certain point, after it rotates, it will reach to a point that the forces are perpendicular to each other and they will cancel each other, okay? But if the forces cancel each other, how is the loop going to continue spinning, or how is the motor going to continue spinning? Now that's the whole trick. The idea is that if we are able to switch the current direction, we will be able to switch the force direction, and in this case we are going to allow for the motor to continue rotating. How is this done? We can make the wire continue rotating by inverting the direction of the force. This can be caused by switching the current direction. Look at the image below here. Now we have these two pieces. We are going to call them brushes. These brushes are connected to a source of energy, in this case a battery. Now, at a certain moment, let's look at the second image here. When the forces are perpendicular to each other and they are canceling each other, look, it's like we disconnected the loop from the battery. There's a small gap on the left and on the right. Here at this moment, the battery is not connected to the brush, okay? But the loop of wire will continue rotating because it still has a little bit of momentum inside it. Now, when it rotates just a little bit more, we will see that these brushes will be connected again to the battery, but on the opposite sides. Look at this brush. Now it's on the right side. When it continues its rotation, this brush will be on the left side. In this case, we switch the current direction. Okay, let's look at this simulation. It will make things a lot more clear. Thanks for ophysics.com for creating this wonderful simulation. I will be putting the link of this simulation in the description of the video. How does this simulation work? Simply, we have a battery. It's connected to two brushes. We called these brushes before, and these brushes are connected to a loop of wire. This loop of wire is passing through a magnetic field. Here it's going from the north side to the south side, okay? Now, let's run the simulation. The object is now rotating. At a certain point, when it's perpendicular, right now, just before these pieces of the wire leave touching the brush again, at this second exactly, you can see that there is no more current passing through the wire, so there is no force. Why is there no more current? Because there's a gap between these two brushes. But the loop will continue rotating because it still has a little bit of momentum going in it. So let's continue the simulation. Look here, what's going to happen here, let's stop the simulation. this part of the wire used to be touching the blue brush. Now it's touching the red brush. So what we did is that we switched the current direction. By switching the current direction, we switched the force. And that's how a motor works. Okay, finally, can we increase the speed of this rotation? In other words, can I make the force larger on this wire? Exactly, we can do that by changing these three factors. If we increase the magnetic field, it will start going faster. The other factor is increasing the battery voltage. In other words, we are increasing the current. So if I increase the battery voltage, you can see that it's spinning faster right now. And finally, if I increase the number of loops, I am making it even faster. Actually, if you go back to the lesson where we covered the forces on wires passing through a magnetic field, we used to say that the force is equal to I multiplied by L multiplied by B. I was for the current, where we can change the current by changing the voltage of the battery. L is the length of the wire. We are increasing the length of the wire by increasing the number of loops. And finally, B is the magnetic field. Increasing the magnetic field using larger magnets, for example, will also increase the force applied on this rotational movement, and it will cause it to go faster. That's the concept behind how a motor works. Stay tuned to see how a generator is used to generate electricity.